Okay, so today we're going to talk about how to find the areas of regular polygons. This is a two-part section, depending upon the given information. So part A, we're only talking about given the side length. Part B, we'll talk about given the radius of the polygon. So a regular polygon is a polygon with all sides equal and all angles equal. Another property of this regular polygon is going to fit in perfectly inside a circle, such that the vertices of the regular polygon all meet on points on the circle. The center of that circle is also considered the center of the polygon, as long as it's going from the center all the way to one of the vertices. So we're going to use that information to solve later area problems, but again, not today. So just remember, this is the radius right here of your polygon, radius r. Now the apothem is the perpendicular distance from the center of the regular polygon to a side length. So again, if I go back to this slide, if I were to draw a perpendicular line, we form this shape right here, where this perpendicular distance right here is our a value. And notice we form a right triangle. Because it's a right triangle, we're going to be solving a lot of right triangle trig problems. Another thing is the central angle of the regular polygon is equal to 360 over n, where n is the number of sides. The central angle is the angle that goes from, if I were to connect two vertices, the radii, this right here is your central angle, which I'll just call CA. It is important, though we're not going to really be using that particular angle to solve our right triangles. We'll talk about the angle we do want to find out. So finally, the area formula. So the area of a regular polygon is 1/2 a and s, where a is the apothem, that perpendicular distance, n is the number of sides, and s is the side length. Now, for the most part, we are never going to be given the apothem for these regular polygons. You'll obviously be given the number of sides because you'll know it's a pentagon, which is n is 5, or a decagon, n is 10. And you'll be generally given the side length, and that's what today's lesson is, given the side length. We'll be able to use that information to solve for a, so I can then get the correct area for this regular polygon. So again, the key to doing that, as I kind of alluded to, was solving a right triangle problem. Well, this is the right triangle problem we want to solve, where this distance right here is our radius, which is not going to be relevant for today, but will be relevant in the next lesson. This perpendicular distance is our apothem. And they also have these two other values, which I'm just going to call x and y. X is this angle right inside here for the right triangle. And the value for x is actually half the central angle. So if we find the central angle by doing 360 over n, we'll find x by doing 180 over n, where again, n is the number of sides. And this y value right here, well, if I were to go back, is this equivalent to this piece right here. So again, if x is half the central angle, and y is a piece of the side length, it's also half the actual side length. So as long as we're given the side length, we'll know what y is. And as long as I know the number of sides, I'll find x, and I can use that right there to solve for a. Because in terms of x, the angle, y is always opposite, a is always adjacent, and r is always the hypotenuse. So if I want to solve for a, given y, it's always going to be a tangent problem. So tangent of x equals y over a. And that's what we're going to solve every single time for one of these problems. So for example, we are given a pentagon with side length of 6 inches. So if it's a pentagon, it tells us n is 5. We are given that s is equal to 6. So we need to solve this right triangle for a to find the area. Well, I need to fill in the two blanks. I need to fill in the angle. I need to fill in this side length. Again, y is always s over 2. So y is 3. And then the angle is always 180 divided by how many sides there are. So since n is 5, we're going to do 180 divided by 5, which is 36. So now to solve for a, again, opposite is 3, adjacent is a, so it's tangent. So tangent of 36 equals 3 over a. So I put this over 1, I cross multiply. A tangent 36 equals 3. We divide both sides by tangent of 36. And when we do 3 divided by tangent of 36, you're going to get 4.129. Now, as we've dealt with for most of our right triangle problems, it's not going to be an exact answer, so make sure you store it so you can find the area correctly. Area is 1/2 the apothem, 4.129, times the number of sides, times the side length, A and S. We do all that exactly, you're going to get 61.937. It's inches. Since we're talking about area, it's inches squared. And there we go. So we're going to be solving the same particular problem, only now we're going to talk about different shapes. We're going to talk about different actual side lengths, but still the same concept given the side length and the shape. And an S given to you, identify X and Y, set up your trig problem, tangent of the angle equals Y over A, solve for A, plug in to solve for the area. So take a look at this one. We have a hexagon, side length 12 meters. So we know if it's a hexagon, N is 6, and we know side length is 12. So our Y value is half the side length, so 12 over 2, which is 6. Our X value is 180 divided by the number of sides, which is 30. So we have this right triangle, that's 30 degrees, this is 6, and that's A. Now we can't use right triangle trig here because you should recognize the 30 degrees as one of our special angles. If that's 30, that means that's 60. So we have a 30, 60, 90 right triangle, where opposite of 30 is considered our S value. Opposite of 60 is that value times square root of 3. So if this is 6, A is 6 square root of 3. So you're going to typically find, you're always going to find for a hexagon that the A value is always half the side length with a radical 3. So if this was 50, this value right here would be 25, radical 3. So hexagons are going to be pretty nice and easy. They allow you to skip a couple steps. So your area is 1/2 the apothem times the number of sides times the side length. Now, the radical 3 I don't want you to leave as a decimal, so make sure you ignore it. Do half of 6 times 12. You're going to get 216 square root of 3 meters squared. Again, just the nice thing to deal with when it's a hexagon. It's going to be a special one. No other shape will be a special that we're going to deal with, only the hexagons. So for all the other ones, you actually need to still solve the right triangle problem. Like this one. We'll do one more together, and then you can do one on your own. So the octagon has side length of 15.2 inches. So octagon, N is 8. Side length S is 15.2. So our Y value is half of the side length, which is 7.6. Our angle is 180 divided by number of sides, which is 22.5. So we have this right triangle then. Again, 7.6. The angle opposite is the 22.5. The apothem is the side we want to find. So again, opposite and adjacent, so we're going to use tangents of the angle equals opposite over adjacent. So I cross multiply. We're going to divide by the tangent of 22.5. When we work that out, our A value is going to be 18.348. Again, not exact, so make sure you store it so you can use it correctly. Because in your area is 1/2 the apothem times the number of sides times the side length. And again, using the exact answer in your calculator, you should get an area that's 1,115.560 inches squared. Okay, so that's how we're solving these particular problems. Key is identifying N and S from the given information, should be very obvious. Finding Y and X from that. Again, you're taking half of S to find Y, doing 180 divided by N to find the X value, setting up your triangle, and it's always going to be tangent given the side length. When we talk about radius next time, you're going to have to do two things. It'll be sine and cosine. So I want you to go ahead and solve this one on your own. Identify n and s, and then use that to find y and x. Set up your right triangle, solve for a, get the area. So go ahead and pause the video while you work that one out. Okay, so the given information tells you since an 18 gone, n is 18, s is 8.1. So if I cut 8.1 in half, I get 4.05. I do 180 divided by 18, I get 10. When you solve that particular right triangle, you should get the apothem to be 22.967, which when you plug back in gives you a final area of 1,674.418 feet squared. Okay? And again, if you didn't get any one of those answers, just simply pause the video, go back to where you did your work, compare it to what we did for the previous problems. It's the exact same setup. The only difference is we have a different y and x values to plug into the problem. Other than that, it's the exact same setup. Alright, so your homework for class next time is worksheet 11.4a. It's going to be dealing with a bunch of these problems, finding the areas of these regular polygons given the side lengths. And again, next time we're going to talk about the radius. So I'll see you next time.